Hello everyone, welcome to our stellar video, and we are really happy to be here. We are going to write a token contract with you, so we are so happy and so excited to be with you guys today. So here are token contract file, and we have our cargo toml file. First, let's have a look at cargo toml. So we have Sorbon token contract here. It should be the same with the Sorbon token contract in here. And we have our description. Is it needed? Not really, but if you want to put it, why not? Our version and our edition. In here, our crate types. It should be here to make everything work. And our dependencies, it is Sorbon SDK and Sorbon Token SDK, their versions. And for development dependencies, it is the Sorbon SDK and profile releases with logs, so they should be here. So first, let's start with our main part, libRest. So how are we going to start it? By writing cargo new, let me just write it here, dash dash lib and name of our project. And if you just can write it in here on your let's say terminal, it will just start this project directly. So let's start. First, I'm going to go with no, you're not going to use the standard cargo. So that's why we have our main files in here: admin, allowance, balance, contract, metadata, and storage types. So we are going to go with them. So first, let's go with the admin, and then let's go with the allowance, and then let's go with balance, and then what do we have? We have contract. Let's go with this, and also what do we have? Metadata, and lastly storage types. And what do we need is public use for the crates, and you should get it from the contract, and you need to use token client in the end. So this will be our starter for our libRS. So in here, those modules will be connected to these RS files, and then what do we put in those files will be directly opened in our main file, which is libRS. We started with the libRS. We put our modules in here, and now let's go with the admin rs. So in the admin rs file, guys, we are going to use some important matters, some important points. First, let's start with the use Sorbon SDK, and then it should be connected to the with the curly parentheses address, and also with the environment. So this is our first part, and then we are going to use with the crate actually, and then we will go with the storage types, which is connected to actually what we do, and we will put a data key to make sure that everything is stored. And then we are going to create a new public function, and we will name it as administrator. Let's go with the name, and then we will add an argument, name it A, and we are going to put a reference as the environment as a reference, and then it will return the address directly. It will return a bool to make sure if the address is correct or not. And in curly parentheses, we are going to write our codes. First, we are going to start with a variable as a key variable, and we will put a data key, and we are going to use it from admin. And what do we need to do is just to store it to storage part, and from there we're going to put it into an instance, and then we are going to put the key, so we make sure that it is actually secure to use it. So this is the first part, and then we will go on with another function, and we will name it is read from administrator, because we're going to go with the admin. And in here we are going to put the same and take it from the environment once again. And this time it will return the address. And inside the address we are going to put our codes. First we are going to create a variable named key, and it will be our data key, and it will take it from the admin once again, and we are going to store it again, and we are going to put it into an instance so it could just go with it. And we need to just get this key as a reference from key, and then we need to unwrap it to make sure that it works. And last thing we need to do for the admin part is that we are going to with the function, and this time we are going to read from the administrator, and again our argument will be again e, and we are going to take it from the environment. And this time we are going to add the ID as reference from address, so it will make sure that it gets the information from the contract file. And we have going to another actually the same let's say variable with key, and we are going to use the data key, and we are going to use the admin. And again we will do the same things, so we can just directly copy and paste it, but we are going to change a few things in the end. So after this we are going to we are going to set it with the data key, we get it as a reference, and then we will use the ID. So this will be our admin part. We finished with the admin arrest. So now we are going to go with the allowance, but the allowance part will be a bit long. So please, you make sure that you can keep up with me. So let's go with the allowance. So first we are going to use create, and then we are going to use the source types. So that's why we have it. And then in source types we are going to have the allowance data key, and we have the allowance value. So let's go with the data key. This will be the last part. And then we are going to use Soran SDK, and it will get the address, and it will get the environment once again. So now we are going to start with our function. So we are creating a public function. We are going to give it a allowance with the read part, and it will read the e part, and we are going to reference from the environment again, and from where will it read from, it will read the address from the spender, and in the spender we will have the address once again, and it will return the allowance value to us. And inside the allowance value we will have our key, and it will get it from it will get information from data key. It will have the allowance once again, and inside the allowance we are going to use allowance data key, and the allowance data key, it will get the allowance data key from the spender. So this is our first part, and we are going to check if the information we get is correct or not. So we will go with if let this time. If let sum allowance, so it should be equal to e, and storage we get from the storage, and it will be saved into the temporary file, and again we will use our get, and variable get as a vector. It will get from the allowance value, and in the allowance value it should store our key once again, and inside there we're going to actually check again if allowance in the expiration ledger, and in the expiration ledger it should consist again our E with the ledger, and we will have the sequence, and inside that sequence we will have the allowance value, and inside the allowance value we will have an amount which will be 0 for the time being, and we are going to put the expiration ledger, and it should be go on with the allowance and expiration ledger. So, and we are going to go with else. So in the else it should be allowance part, and for if flat we are going to go with else again, and in the inside of else it should be allowance value, and with that said we are just going to put the amount as 0, and we are going to put expiration ledger as 0 in here. So this is our first part, and right after that we are going to go with another public function. This time it will be for writing allowance, and inside here you can just think about it like the structure enum in Rust. In there first we are going to have the E. Again, we are going to get reference from the environment, and we will go with from. Inside there will be the address, and the spender should be again the address, and the amount it should be with integer 128, and from the expiration ledger it should be I32. Let's go with an integer because it should be unsigned integer, because we're just going to make sure that there will be no negative numbers, and inside that we are going to have our allowance variable, and inside this we have the allowance value, and inside the allowance value we need to have the amount, and we need to have the expiration ledger, and we will put a stop to our file. So let's just go with this, and right after that we are going to go with the if part in here. So if our current amount, as you know, we just set it as 0. If the amount is bigger than 0, so what should it do? It should just create another variable. So it will just go for the for, and the expiration ledger it should give, and from this part it should have the checked sub. We will just go with it, and inside this it should again have ledger, and lastly the sequence, and also it should go with the unwrap. So this is our if, and actually we are going to add one more thing inside if. So let me just go like this, and this time we will also add inside E storage we will have the temporary files once again, and we have to use the extend TTL, and then it should extend it with our reference key and our new variable live4, and again live4. So this part we should understand that it gets 3 arguments with extend TTL. So if you just go into it, it will just explain you what does it do, so you can check its meaning from there as well if you wish. So now let's save it until now, and then let's move on. So and then we will have another function, and this time it will be this spend the allowance, and inside this we are going to go with our E, and it should take the environment once again, and this time from address spender, and inside the spender we have the address once again, and we have the amount, and we will go with the amount I-128, and inside this what we need to have is again the allowance variable. It should have the read allowance inside, and in the read allowance as arguments we put E, and from clone, so it should use the same example, and then we go with spender dot clone, and we are going to go with if this allowance dot amount is smaller than the amount itself. What should we do? It should panic, which means it should give an error. We will use the macro in here, and we are going to say insufficient allowance. So that means that we don't have the exactly needed money for this one, and it will write the allowance, and in the writing allowance it should consist the E again from spender allowance the amount, and minus amount, and allowance dot expression ledger. So inside it should consist those files. So this is our allowance file. I told you it was a bit longer, but if you have any questions you can just directly ask through the comments section. So this will be our allowance part. Now as you remember, we finished libRS, we finished adminRS, we finished one of the long codes, allowanceRS, and now we are going to go with the balanceRS. So in the balanceRS, it's not that long just like allowance, but we have some important parts in here. So let's start. First, again, we are going to use the create from the storage types, and inside the storage types it should consist again with the curly parentheses. So this time again the data key, so and then we have the balance bump amount, and we have the balance lifetime threshold. So we are going to explain them, and then we are going to use again the Soran SDK, and from here again it will just get the address and it will get the environment. And let's move on with our new public function, and inside the public function we have the read balance, and inside these arguments we put again our E, and we get the environment in here, and we will have the address, and it will return integer with 128 bytes. Inside that we have our again the key variable. Inside the key variable we will have again the data key, and inside that we will have this time our balance, and inside the balance it will consist the address. So again, we will check, everything is correct or not. So if we will go with, if that sum balance, and this balance should be equal to, again, our our storage, and also it should be persistent, so it shouldn't change, from time to time. And we will have the get again with the vectors, data key, and I 8-bit, and it will just take the reference key, and inside the reference key we will have this the storage from what we get from the storage, and in the storage it should be persistent, and also it should extend TTL. So what should it entitle? We will go with the reference key again, and we will go with balance threshold, and also we will go with balance bump amount. Okay, and it should return the balance, and else it should return 0. Okay, so this is the first part, and then we will have another function. We will go with the balance. So inside this function, we will use write balance this time. We are going to write the balance information, and again it will have the E argument with the reference of environment, and we will have our address, and inside it will have the address, and it will have also the amount, and the amount should be with 128 bits. And inside this code, what we are going to add is that first we are going to have the key again. It will again get the data key, and this time balance and address again, and this time we are going to write the balance. So we are asking it to write it, and then we will have the E storage in here, and then it should be again persistent, and it should this time we first get it. Now it should set it by using the reference key and also the reference amount, so you can see the result. And then we will have the E storage again, sorry, and it should store. This time what should it store? It should store the persistence, and again it should store the extend TTL, and inside again we will have the reference key and the balance threshold, and we will have the balance bump amount inside, and we are closing this parenthesis, and we will move on. And then this time we will have another public function, and we will receive the balance this time, receive balance, and with the receive balance again we will have our E. We will take the environment reference, and it will again have the address, and it will have again the amount as I-128, and inside this code we will have our balance. This is our variable, and it should take from read balance, and inside and as an argument we have the E, we have the address, and we have the clone of the address in here. And then it should write the balance as an argument. It takes 3 arguments, E, address, and balance plus the amount. And then we are closing with semicolons. Okay, now and we are coming to the last part with another function. So we will go with the pop function, and we are going to use spend balance this time, and again we have our E as the environment, and we will have our address as address, and we will have the amount as again I128, and inside this code we will have the balance again as a variable, and the read balance again, this time it will read from from address clone, so we just use this, and we will go with if balance is smaller than the amount, it will return an error, it will panic. We will use panic macro again, and we go with insufficient balance. So we are making sure that we have the sufficient balance to do the work, and inside it will just write the balance, and inside the balance we will have address and balance, this time minus amount. So this is our balance part. So thank you for listening, and see you in our next video.